Hello students, today we are going to see an interesting and important topic, that is colors in coordination complex compound. Actually, the great achievement of CFT theory, which is having the ability to explain the colors of the coordination complex compound. You know very well, most of the transition metals are in colors. So what it as transition metals are doing, it absorbs the light from visible region and it splits, that means it transmitted into colors. As you have learned in physics, even chemistry also, the light passes through the prism. Actually, white light passes through the prism and you are getting a wonderful beautiful colors, that is WebGR. So from lower wavelength to higher wavelength, so from white light turns to different colors. The same way, coordination complex compound of solid state or in solution form, it absorbs the white light and shows in a different color, depends upon their complex compound. That is explained by crystal field theory. Yes, come on, let us go for that point. Now here, beam of the light passes through the sample. Here sample means nothing. Coordination complex compound. It may be a solid form or in a liquid form. Whatever it may be. It absorbs the light and it transmitted in a different color. The same like only. But something different. Yes, I would like to mention here. As the light passes through the prism, you know seven wonderful colors. You know very well, that is WebGR. Okay, now in that lower wavelength to higher wavelength. For you to remember here, I just made it as a chakra for you. Okay, so in that chakra here, I just mentioned a main important colors only. So in that lower wavelength to higher wavelength, I just put it in that way. So here, coordination complex compound, it absorbs the white light from higher wavelength to and it transmitted into a lower wavelength. So for example, longer wavelength 800, it's a red color and it appears as a green color. So that is what I just mentioned: red, orange, yellow, violet, blue, green. So red, orange, yellow, ROY, Roy, up of circle, and VBG, down of circle. So in that way, you just to remember, so that you will come to know very clearly. Suppose that complex compound appears as a green, so the coordination complex compound absorb the light and it comes from red color turns into green. Actually, it absorbs red, but it shows green. That is what it has mentioned. Complementary colors. Yes, let us go for that. What do you mean by complementary colors? Longer wavelength red light absorbs from the white light and turns into green. So the color we see the complex of a solid or in a solution form, due to the light absorbs and transmitted. So that is called what it is, complementary colors. That is what I have given a clear idea for you to remember. ROY, BBG, up ROY, down BBG. Now suppose the coordination complex compound absorbs white light. It first, it might be shows a orange and opposite color what it can appear. How do we appear? What color we can appear means blue. And the same way violet. Sorry. Yeah, violet. Violet color means lower wavelength and it shows yellow. The same way blue color, it absorbs means it shows orange. Green color, it absorbs means from the white light it shows red. So in that way we can identify. I hope this trick will help you to find out number of examples. Yes, it is standing in the queue for you to get that more ideas of the examples. Yes, let us go for that examples. Actually, this chakra, what it tells you, know, coordination complex compound, it absorbs the white light and it absorbs a higher wavelength and transmitted into lower wavelength. That means it appears as a lower wavelength. So, from the white light, it absorbs red color, converted into, it appears as a green. Suppose orange, from the white light and turns into blue. That's all. See, from ordinary person to higher level, see, that is a dynamic changes, Dr. Great Abdul Kalam, ordinary person to missile man. Imagine in that way. So even in your life also, ordinary level to higher level, the same point I just bring it to you. Okay. Now come to this point. Transition metals are having one plus point. What it is, it is having the d orbital. The d orbital is having two different energy level. So what are the two different energy level? That is dxy. Yes, I can hear your voice. dxy, dyz, dzx. The same way here, dx square minus y square and dz square. So this is called T2G and this is called EG. So this is a higher level and this is a lower energy level. Okay. Now imagine this is a compound, coordination complex compound. So coordination complex compound, the light passes. So actually the electrons are filling in the lower level. Imagine the electrons are filling in the lower level. So what happened? Electrons, this is a ground state. When light absorbs, naturally electrons are raised up. So what happened? The electrons goes from lower level to higher level. That's all. Okay, now this is electronic configuration. Suppose if it is here means T2G to EG0, right? Suppose here fills means, so when the light passes, so light passes means naturally EG2 T2G0 it turns. That's all about this explanation. Now I'll take one example here. TiH2O 6 times 3 plus. This is one liquid solution, one compound, coordination complex compound. Titanium, electronic configuration, actually it is 21, right? So electrons definitely only one in the d orbital, right? 21. So only one in the d orbital. So when the light passes through this compound, so electrons are raised up. So naturally it goes higher level. So here electronic configuration 1 and here 1. Where it is 1, that is the main point. T2G level to EG level. T2G level, it turns into EG level because electrons are raised from ground state to excited state. That's all. Okay, actually, this is looks like purple. This looks like purple. So this compound, the solution of the compound, it absorbs the white light and it turns into different color. Actually here yellow and green, it absorbs from the white light and it shows what it is, red and violet. Okay, it absorbs from the white light. It absorbs what color? It absorbs yellow and green. It absorbs from the white light, that is radiation. It absorbs and emitted what color? It is red and violet. Okay, so from higher region to lower region or from lower region to higher region, just to the opposite. So please you remember ROY and VBG, like you just remember this chakra. Okay, now according to the wavelength we can find the energy also. Yeah, I just bring the same example. TiH2O 6 times 3 plus. You know the name very well, right? Hexahaqua titanium 3 plus ion. Okay. Now here wavelength, this is 510 nanometer. So energy, how to find out? E equal to h nu. You know very well. Grade 11 you have learned. So h it is what it is, Planck's constant. So h c by lambda. Nu equal to c by lambda. Now h it is what it is, 6.626 into 10 to the power of minus 34 joules a second, and C 3 into 10 to the power of 8 meter second inverse. Okay, now next one, lambda. Just now they have given 510 nanometer. So that means nanometer. So you just put it in that term. 10 to the power of minus 9 meter. Okay, now you just apply that value equal to 6.626 into 10 to the power of minus 34 joules second into 3 into 10 to the power of 8 meter second inverse divided by 510 into 10 to the power of minus 9 meter. That is nanometer, right? Okay, now what is the value you are receiving? When you are receiving that value 3.90 into 10 to the power of minus 19 joule you will receive. Okay, now suppose you are going for that to identify that each electron. Now this is only one electron which is excitation. So when that excitation to absorb one electron, see here, energy excitation of one electron, that is energy absorbed 1 mole of an atom. So E equal to 6.023 into 10 to the power of 23. 1 mole of an atom we converted. No, 1 electron, 1 mole of an atom into here this point. 3.90 into 10 to the power of minus 19 joule. So naturally equal to what you will get it? 2.35 into 10 to the power of 5 joule you will get it. Okay, now titanium, that is what it is? H2O 6 times hexa aqua, titanium 3 plus ion delta naught. You know delta naught. That energy is equal to what it is? 235 kilojoule. We just turn into kilojoule. Hope you're clear. So this is the way you can identify. They will give the wavelength. You just identify. This is already you have learned this method in that what it is grade 11, how to find out the energy level when they are giving that wavelength. Hope you're clear with it. Okay, now we are going to see the nature of the ligand. According to the nature of the ligand, different complexes absorbs different energy from the visible region and exhibit different colors also. Okay, now let us go find out some examples here. COH2O 6 times 3 plus CONH3 6 times 3 plus COCN 6 3 minus. Actually, nature of the ligand we can identify what are the complex compound. Okay, now as you see the ligand, you will come to know which is a weak ligand and which is a strong ligand. We'll write it in an increasing order. H2O, it's a very weak ligand. NH3, okay, fine. And which is a strong ligand? CN, it's a strong ligand. Okay, now next one, we are going to find out all these four ideas. Delta G value we have to find out. Excitation value, that is excitation. Delta E value, that is energy level, we have to identify. Absorption of wavelength and the color. What is the color? It is transmitted. Okay, now delta value, delta naught value, actually it is very small because it is a weak ligand. So it is small. And NH3, see, why it is small, why it is large, that last video, in our last video, you just go and observe, you will understand very easily how do we identify delta naught. Delta naught is greater than P, delta naught is lesser than P. You please watch in our last video. Okay, now, yeah, the next one, here's intermediate because it is middle, intermediate. Intermediate. Okay, comparing, we are comparing these three, right? So this is large because it is strong ligand. Okay, now delta E value also the same. Here small because last some we have gone through, no, delta E. What it is? Energy level. Same, intermediate, intermediate, and this is large. Okay, see, absorption wavelength, it is actually OBV. As I mentioned, OBV only, you will come to know the trick. Chakra we will go. Let us go for the chakra. What is the chakra? R, O, Y and B, B, G. Okay, I just mentioned what it is. OBV. O for orange. This compound, orange color, it, what it is? Absorbs from the white light. The same way, this is blue, I just mentioned. orange. For us to remember OBB I just mentioned. Blue and violet. Okay, now here, what is the transmitted color it might be? So this is what it is. Orange color. ROY. Right. Orange color. Just to the opposite, what color it might be transmitted? Yeah, I hope you got an idea what it is. Blue. That's what I just mentioned, the chakra. So from the chakra you will get, because why I'm giving this trick, choose the correct answer. You may get such kind of question. So you just to remember this chakra, that will help you. Okay, some tricks if you follow means definitely you will get one full mark. Okay, now next one. The same way, blue. What is it? Here, of course, just to the opposite, what it is? Orange. Then, is it visible? Yes. Okay, now next one, violet. Yellow. Okay, so here ROY, red, orange, yellow, and VBG, violet, blue, green. I hope you got an idea. So this is the way you can identify that color of the compound and the nature of the ligand. I hope you got a clear idea about that. Okay, some more examples. Let us go and identify. Now, very important points to be noted in the color of the coordination complex compound. See, first point, transition metals are color incomplete d orbitals. So, incomplete d orbitals, dxy, dyz, dzx, dx square minus y square, dz square. So, the filling of orbitals will be incomplete. Then only the complex of the compound will be colored. That is one point. Second point, completely filled or empty d orbitals, it is a colorless 100%. So please check and keep it safely, all those important points, because always it will help you for the choose the correct answer. And next, one more point, absence of ligand. Suppose the ligand it is absent, crystal field splitting does not occur. So absence of ligand, because of that ligand we are mentioning it's a color of the compound. So absence of ligand, there is no color, it is a colorless. Okay, now one example, let me ask the question. CuSO4, what is the color? Everybody will say it is a blue color, sky blue color, ma'am. Yes, we know very well. Actually, CuSO4, generally if they are giving CuSO4, anhydrous CuSO4, anhydrous CuSO4, it is white color. But CuSO4 5H2O, that is only hydrated complex. So for CuSO4 5H2O, it is blue color. As you said, it's a sky blue. Okay, please remember CuSO4. Suddenly, if they are asking what is the color of CuSO4, it's white color, because anhydrous, they did not mention 5H2O. Suppose if they are mentioning, definitely it will be bluish color, as you said. Next one, the same idea. TiH2O 6 times Cl3. As we were mentioning that example, no, it's very important, because in CBSE board level question we have gone through 3-4 times. It has repeated the same question. Even that wavelength, all those sums also it has repeated. So please remember this point. TiH2O 6 times Cl3. Actually, it is a purple color. Okay, but while heating, it will become a colorless. Why? While heating, it is evaporated, so it will become a colorless. So depends upon the ligand, color will be identified. And one more thing, incomplete orbitals, color will be there. Incomplete orbitals, color will be there. Completely filled orbitals or empty orbitals, there is no color. So please remember all these points. Hope you got a better idea about that color and coordination complex compound. Please subscribe this channel and you will get all the notification if you hit the bell icon. Thanks for watching.